Hello, welcome to the FRQ of the day. So today we're going to do the 2012 number 2. So let's see if we can figure this one out. So this one says a charity fundraiser has a spin the pointer game that uses a spinner like the one illustrated in the figure below. A donation of $2 is required to play the game. For each $2 donation, a player spins the pointer once and receives the amount of money indicated in the sector where the pointer lands on the wheel. The spinner has an equal probability of landing in each of the 10 sectors. Part A. Let X represent the net contribution to charity when one person plays the game once. Complete the table for the probability distribution of X. Part B. What is the expected value of the net contribution to the charity for one play of the game? Part C, the charity would like to receive a net contribution of $500 from the game. What is the fewest number of times the game must be played for the expected value of the net contribution to be at least $500? And then Part D, based on last year's event, the charity anticipates that the spin the pointer game will be played 1,000 times. The charity would like to know the probability of obtaining a net contribution of at least $500 in 1,000 plays of the game. The mean and standard deviation of the net contribution to the charity in 1,000 plays of the game are $700 and $92.79 respectively. Use the normal distribution to approximate the probability that the charity would obtain a net contribution of at least $500 in 1,000 plays of the game. So if you want to pause the video and give this one a shot, that would be great. Okay, so first of all, it asks us to, so X represents the net contribution to charity. So they're paying $2. So if they spin a 0, that means their net contribution to the charity is $2. And if they get a 1, that means they're contributing $1. They're paying $2 and getting 1 back. And if they get the 10, that means they're winning $10, but that would they would win a total of $8. But the charity would lose $8. And so what's the probability of getting a 2, or of contributing $2? What that means is you pay $2 and you win 0. And so that occurs, we just count the zeros, 1, 2, 3, 4, 5, 6. And so that's going to be 0.6. All right, what's the probability they contribute $1? Well, that means they roll one of the $1 ones, and that's just 1, 2, 3. So the probability of that is 3 out of 10, which is 0.3, and then that occurs once. The $10 occurs once, which means it's -8 to the charity, and so that is 0.1. And so that is all there is to that's all there is to Part A. What is the expected value of this? Now, the expected value, you may recall, this is a discrete random variable, and in regards to a discrete random variable, the expected value, otherwise known as the mean, is just every x times every p, and then add them up. There's the standard deviation, by the way, which you didn't have to find in this problem. But so there's the mean, every x times every p, and then add them up. And so you would just say, well, you would just say 2 times 0.6, and that is 1.2. And then 1 times 0.3, and that's going that times that, and so that is 0.3. And then lastly, -0.8 times 0.1, and so that would be -0.8. And so then you would add those up. And you would get, that would add up to 0.7. And you could show your work just like that if you wanted to, actually. But here's the way I showed my work on another piece of paper. So that would be Part A. And so this one, I just show the multiplication and addition to show your work like that. And so 0.7. So that is the mean. And so that is the average per winnings. That is the average winnings per play that the charity is expecting to make. In other words, in the long run, on average, they're expecting to make 0.7. And in my opinion, in that year's exam, that's what is more likely to be asked, to explain the meaning behind things. What does this mean? To interpret this value. Well, it is the average number of winnings per play for the charity. They're expecting to make 70 cents per play on average. All right, and so then Part C, it says the charity would like to receive a net income of $500. What is the fewest number of times the game must be played for the expected value of $500? So in other words, we're expecting 70 cents per play. So how many plays do we need to get to 500 on average? And so you just set up I just set up a little equation. I called it Y because X had been defined as something else. So Y is the number of times the games is played. So 0.7 or 70 cents times the number of times played is going to be equal to 500. And it says at least 500, by the way. And so I just solved this for Y, and so I get Y, the number of times played is that. Well, but it wants at least 500. So on the 714th play, we're expecting it to be 499.8. And so on the 715th play, we're expecting it to be $500.50. So therefore, the answer here is on the 715th play, the expected game profit goes above $500 for the first time. So the 715th. And so showing your work there is just showing that arithmetic right there. And then the last part of this problem asks us to make a normal calculation. It says the mean and standard deviation are the mean is 700, the standard deviation is 92.7. It says use the normal distribution to find the probability you get at least 500. Okay, and so here's the curve we're working with, a mean of 700, standard deviation of 92.7, right? That. So 500 is over here on the left. So it's saying what's the probability we're going to get that or more? And so that is the area of this normal curve that is greater than that. And so you can just, so when to show your work on this, you would just have to show this to get full credit. Okay, have to go normal CDF from 500 to infinity, mean of 700, standard deviation of 92.79, and you would end up getting that, okay? But frequently, you'll be asked to, I encourage you to always draw the curve and to show the shading, and you'll be asked to find the z-score many times. And so there you go. And so that's it for the FRQ of the day. Thanks for paying attention. Please, if you have any questions, please send me some.